Okay. Find the solution of this following linear system. So again, the way that we find a solution for this type of differential equation is that we got to assume the answer of x1 and x2 in the term of k1 times exponential of lambda t for x1 and x2 is equal to k2 times exponential of lambda t. And then we just plug our assumption back into our linear system. And in our linear system, we have first derivative of x1 by t and first derivative of x2 by t. So we got to do the first derivative of our assumption and then plug it back in the equation. Okay, so we would get dx1 by dt is equal to k1 lambda exponential of lambda t, and again for x2 we would get k2 lambda times exponential of lambda t. After we got this, then we just plug everything back into our linear system. So we would get k1 lambda times exponential of lambda t is equal to 2 k1 times exponential of lambda t minus 3 k2 times exponential of lambda t. And our second equation, we would get k2 lambda times exponential of lambda t is equal to k1 times exponential of lambda t minus 2 k2 times exponential of lambda t. Again, every equation in here, every term of the equation, we have the term of exponential of lambda t, so we just divide equation 2 and equation 1 and 2 with exponential of lambda t. So we would get k1 lambda equal to 2 k1 minus 3 k2. k2 lambda is equal to k1 minus 2 k2. And then we just arrange the equation again by move the k value into the same side. So by doing that, we've got 2 minus lambda k1 minus 3k2 equal to 0, and also k1 minus 2 plus lambda k2 equal to 0. This is equation 3 and equation 4. So from this, we can write down our characteristic equation. Okay, we would get the determinant of 2 minus lambda minus 3, 1 minus 2 plus lambda equal to 0. And then to find this determinant, okay, we would get minus 2 minus lambda times 2 plus lambda plus 3 equal to 0, minus 4 minus lambda square plus 3 equal to 0. We got lambda square minus 4 plus 3 equal to 0, or lambda square minus 1 equal to 0. We got two values of lambda, which is lambda plus 1 and minus 1, which is the unrepeated real root. Again, the way that we are going to do is just that we plug lambda equal to minus 1 and 1 into either equation 3 or 4. It doesn't matter, you can put in 4 or you can put in 3. You would get the same result. Okay. So the next step is just put lambda equal to minus 1 into equation 3. So we would get 3k1 minus 3k2 equal to 0. So our k1 is equal to k2. So then I just assume k1 is equal to 1, then k2 also equal to 1. So the first set of the solution is x1, x2 as a function of t. It's equal to 1 exponential of lambda t. That is our first set. And then for second set, we got to put lambda equal to 1 into either equation 3 or 4. So by that, we would get k1 minus 3k2 equal to 0, or k1 is equal to 3k2. So it just assume k2 equal to 1, then our k1 equal to 3. So our second set, the second set of the solution is x1t and x2t is equal to 3 times exponential of t. So the final solution, the general solution, is our general solution is the summation of our first set of solution and second set solution. So we would get x1t, x2t is equal to c1 times the first set of our solution, which is this term, plus c2 times our second set of solution, which is this term, and that's it.